This is the Woolly controller portal view. Dashboard provides visibility into all your GPU clusters. Every node is a GPU host. Nodes can be NVIDIA or AMD hosts and are managed by a single controller. Groups are a collection of nodes. Tasks are execution requests from Woolly client ML containers. Now, let's see how Woolly Server Scheduler dynamically allocated GPU compute cores across jobs while co-locating them on the same GPU. I created an ML container using the Woolly client container image. This container includes pytorch, the Woolly compiler, and the runtime. I will modify the Woolly config file so that GPU execution requests from this container are routed to the Woolly controller. I can also change the job priority in this config file. The Woolly Server Scheduler uses this priority value to determine the allocation of GPU compute cores when running multiple concurrent jobs. I am also targeting a specific node group for this execution. Then, I execute a sample pytorch llama inference workload. The request hits the Woolly controller in the task queue and is routed to the NVIDIA host in the NVIDIA group. You can see that the inference workload is executing on the GPU with priority P1 as defined in the config file. Since this is the only job executing on the GPU, the Woolly server is not doing any GPU compute core resource scheduling, and the GPU starvation metric is 0. We will see this value change when we execute multiple jobs on this GPU. Let's start a second job. This is my second ML container created from the Woolly client container image. The config file has priority P2, which is lower than P1 for the earlier job we started and targets the NVIDIA group on my GPU cluster. I will now begin a LoRa tuning job. The controller routes this job to the same NVIDIA GPU where the first job is running, and we can now see two jobs running on this GPU. Now, the Woolly Server Scheduler running on this host dynamically schedules the GPU compute cores across jobs, and we can see the starvation metric change from 0 to a high value. This means that the GPU is starved since the job with higher priority is getting more resources than the job with P2. I am now going to start a third job in a new Woolly ML client container. I have set the priority to P3 in my config file for this job, targeting the same NVIDIA group as before. Let's start a vision tuning job. We can see all three client requests in the controller task queue. This third job is also running on the NVIDIA GPU along with the other two jobs. Since it has an even lower priority than the previous two jobs, the server scheduler allocates GPU compute cores accordingly. We see the starvation metric value decrease because one of the other LoRa training jobs finished. To summarize, you can co-locate and execute multiple jobs on the same GPU with deterministic performance management, thereby significantly increasing GPU utilization. Now, let's look at executing ML pytorch containers on CPU-only infrastructure, with kernels running on a remote GPU pool, and you can also run ML workload from the same container on both NVIDIA and AMD GPUs with no changes. This is my CPU-only instance on AWS with no NVIDIA or AMD GPU. I created an ML container from the Woolly client image. In my Woolly config, it's pointing to the Woolly controller managing my GPU pool. Let's run this on NVIDIA host first. So, I will change the group to NVIDIA in my config. Let me start a tuning job. We can see the tuning job show in the controller queue, and it began on the NVIDIA GPU. So, the ML container is running on a CPU instance and not on the GPU host, and the kernels are executing on the remote GPU pool. Let's stop this job and change the config file to run the same job on AMD. It's the same ML container with an unmodified pytorch script that was running on NVIDIA before. I will change the group to AMD in the config file. Let's start the same tuning job now. Note that it's the same pytorch script running on a CPU instance that will now execute on AMD. The job shows up in the controller task queue and is executing on the AMD machine in the AMD group. So, you can run and manage your ML containers on your CPU infrastructure while the kernels transparently execute on your remote GPU pool comprising NVIDIA and AMD hosts. Thanks for your time and visit WoolyAI.com for more information.